Hello everybody and welcome back. I think this is the first, or it is the first video I record in 2023, but I think it's the second video that I'm releasing, but it's the first video I'm recording, so Happy New Year. We are going to continue working on the interpreter, but I want to do something a little bit different today. I want to add support for the pipe operator. And what I mean is the following. Let's add a test case. So we can define functions now. Let's do like this. We define a function that is called add1, which does this. And now I want to define a variable b, which is, let's say, what happens when you do this. So it should be equal to 2. But I want to define a new operator that lets us write this like so. And then we're gonna print b in the end. And we are going to write test and expected. And it should print out 2 because we're taking 1 and then we're putting it into the add function, which has 1. So I quite like this pipe operator. It's not inbuilt in Haskell, but it's quite easy to define. It's built into F#, and you probably also know it from Bash scripting. But I think it's quite nice to have in some cases because you can like define this pipeline of transformations that reads in like a natural way from left to right. So let's try to add support for that. It's also a good exercise for us to like think about how we will, add new things outside of the scope of the book. So the first thing I want to do is maybe not in the parser, but in the scanner, really. I want to add a new token type, I guess. And we'll add it here, we'll call it pipe. And it should look like this, as I already defined. Showed you. So let's see what we have here. Okay, it's gonna be similar to all of these other like 2 character operators. So we will say, okay, if we see this thing, then if the next thing is that one, then we will add the pipe token, and probably we want to make it an error otherwise. So let me just see here if this is gonna work. What does this one do? It takes the character we add now and then advances. So that's correct. Okay. Then if it's not this greater than sign, then we will return an error that says expected at line this thing. It should be a format soft line. Let's just go with that. So now we get a pipe token. We can get a pipe token. Now we have to parse it so that when we get it, we get it in the token stream, we turn it into the correct syntax tree. So I think it should be an expression. And what we want to do is kind of treat it as syntax sugar in the same way that we did with the for loop. And what we want to do is when we see just put it here, when we see something like xf, we want to turn that into a call with some ID, and the callee should be f. We add the parentheses, which really will just be, I guess, the pipe token. And the argument is, of course, x. Something like that. So now where do we add it? So this is the entry point of the parse function. This parser has a set of tokens. And if we're not at the end, we try to get a declaration. And a declaration is either variable declaration, function declaration, or statement. So, I mean, it should probably be in the expression, but let's just go down. Yes, take some. So here in variable declaration, it takes an expression and the statement looks at various statements. Okay, so where we put this transformation over here, where we put that will have implications for the precedence of the operator, and it really would help if we had like the full grammar written down somewhere, and maybe we should do that in another video. But for now I wanted to have quite a low precedence, so it will try to evaluate x and f before anything else, which could be useful if we have something like 2 plus 2 equals, or not equals, piped into f, then it will always try to evaluate this 2 plus 2 first, and it will not evaluate it like this, if you see what I mean. And I think that's most natural, that this is like a breaking point and everything. Yeah, I think that's most natural, at least to me. So let's go into here, expression statement. So it's not really a statement, it's an expression. And an expression here can just be an assignment. Let me look at assignment. So let me think. Maybe we should put it in between here, assignment and or, like as a step between. Because an assignment is like a equals that. It's not this, I think, because this is a variable declaration. Let me just go up and look. Yes, that's a whole separate thing. an assignment is that thing. This thing, a equals 2. And I think it's good to put the precedence of the pipe operator higher than this, so that, for example, if we have this, then it will evaluate the right-hand side first. So it should be down here. So let's call it pipe. Okay. Let me just erase that. And here we'll write something like it's this thing. So first we should get the left-hand side. So let's write expert and F. And then we need to say if the next token is a pipe, then we do something, and otherwise we should just return the expression. And what do we need to do? So this could be an arbitrary thing, and it could also be like two things. So we should say pass an expression. Or should we? Because what do we need to do if it's true? It's a little bit tricky. So anyway, let's see. Let's get the function, and I'm pretty sure we have something called the function expression. But we don't really, well, there could be a function there. We could also have something like this, right? Like an anonymous inline function, which we definitely want to support. And also we could make some lambda function syntax. So we could just have, I don't know, like this. Okay, but let's try to just get an expression. So if it's just like an identifier, then it should be fine, should work fine. What happens if it's two, like a chained thing? Then we will go back into expression, which is like up here. It will again hit this one. Well, let me just okay, let's assume it works, and we should return a call like this one. Let me just see how it looks. And we cannot really, let me say like the pipe is the previous one. So we can give it here, pipe. And then the arguments should just be the expression. So it's more or less this, but I think this will fail if we have a chained thing. Let me go back here and let me define some of these other cases that we're talking about. So we have add 1, add 2. Also, this is wrong, it should be add 1. And now it should print 4. Copy paste that one and just do pipe 3. And what? Weird. Okay, anyway, so now I want to just do this. A plus 2. And that should be the same thing. Okay, so now we have a couple of test cases. This one is obviously not supported yet because we don't have this like lambda thing. But let's see what happens. So the first case, that should work already. Now in the second case, we will pass an expression from this one. Then we will see that there is a pipe operator. Okay, so we enter this part of the if statement. Then we will try to pass an expression from what's left. And when we do that, it will go in and it will pass an expression which will give us f1. Then it will see that there's a pipe operator, and then it will enter here, it will pass an expression, will give us f2. Then it will say, okay, we have a call, and the callee is f2. And the arguments is f1, which is wrong. But then it will go out again of the recursion, will go one level up of the recursion, and then it will say, okay, the call, we have that the callee is this call thing that we just created, and the arguments is the original expression. So we need to do something else. Which is kind of interesting. This is very interesting. So, like by default, but with this way of passing, we have this kind of right associativity. So, like if we had more, then it would pass it like this. But really we wanted to go the other way. We wanted to do like this. So perhaps we should say, okay, we get an expression. Then we see it's a pipe. Then we shouldn't pass an expression. We should probably like pass an or. So like it's one layer down in the grammar hierarchy. And then we should say that the expression is now a call to the function. With the arguments being the old expression. And so let's say while this. Okay, so we get the expression. we see that there's a pipe, then we pass another expression which will like stop at the next pipe, and it cannot be an assignment or anything, which is fine. And once we've passed that, we make a new expression, which is just this parenthesis I have up here, and then we check to see if there's another pipe, and then we do the same thing again. So actually, I think I need to do this. No, that's horrible. But the problem is now we have this, and now I want to say return okay expression. But that's not really what I want, because I want the else as well. So, well, this is fine. Now it's just this in any case. So we'll just say okay expression. So if I'm not mistaken, which I may be, then we kind of have support for it now. Let's try to run it, see how wrong it goes. So let's define a function which takes one variable and just returns +1, and now we have to do this because let's see that it works. That's nice. How about this? This should this should work. This should work. Damn, I thought we had fixed this. Variable A has not been declared. Damn. I really thought we had fixed this. Let me do this. Huh. Okay, let me go over this. Okay, so it was because in some of these tests we were missing IDs in the expression nodes. But anyway, let's try to fix the tests now. So tests, which one failed again? Generic. Test cases, generic. So variable I has not been declared. Okay, it's the resolver that's messing up again. Most likely. So where is it? Has not been declared. Where is it? We do this. It is in the expression. It's not been declared. And actually it's here, I guess. Okay. And let's set it up so we can easily run it. So cargo run tests cases generic like that. And now it's failing with a completely different one, which is amazing. Because of this thing. So that would be nice if this format was like also runnable. But that's for another video. Now I want to say cargo run. Was it like this? Yes, that worked. Let me just check. If the first one is equal to, then we just take it as a string. Perfect. So go back here to the shell and here. Okay, so I can run this code and it will say like a number of things. And then it will say variable I has not been declared. So that's not good. Let's find out what the distance is. The distance is none. Which is fine. So that's very annoying. So it should be made into a while block. So let's see. Distance. Let me go back here and take this one away. Let's maybe zoom out. Distance is none. That's fine. Okay, so let me try something, because this thing should be transformed into something like this. And a boolean is less than 10. And then it should be while the boolean, then we print I and we say I plus equals 1. It did not like that. And what was the problem? So that works. That kind of works. That also, yes, that works. Then we say while this should be okay. Maybe it's and I equals I plus. Let's just do this instead. That was not good. Interesting. Very interesting. Okay, so that worked fine. But for some reason when we do the for loop, then it doesn't work. Let me go into the parser and see. We should have for somewhere. For statement. So it wraps it in a block as well. So just to make sure we have fully tested it, let me say like this. And then there's another block here. Yeah, so now we get the same error. And it's kind of weird that it never prints this message we had, which is also weird. Distance index per variable. So still none. Okay, so probably is a problem in the, well, it shouldn't be here. Correct. Okay, let's go into the resolver. So we should actually be resolving a block statement. Let's just to be completely sure that everything is working. Let's see here. So we resolve something, then we run the interpreter. Wait, so what I want I want it to be one block statement. So let's just check things like statements.length and also the first one. Yeah, doesn't have to do that. So we have one statement which is a block statement, which is correct. Okay, so it's passed correctly. Let's go into the resolver then. Which should go into resolve many. And let's just for now assert here that statements.length is 1 and see that that works. Aha. Well, it should fail at some point. So it should assert that either it's 1 or it's 3. I think that's okay. Maybe not. What do we get here? 1, 3, and 2. So does that make sense? Yes, because inside the while it there should be 2. And it's actually in the right order. So first we get one block, then we get 3 things inside the block, and in the while, in the block and while, there's only 2 things. So it's correct enough. Okay, so then we resolve a statement. It should go directly into the variable statement. So we say resolve variable. We declare a variable. Actually, hold on. So the first we should go into block. In block, we begin the scope. We resolve many. We end the scope. So then we resolve many, and that resolves the variable. So let me see here. Let me write print length. Self.scopes.length. Scope length. That's interesting. Why? Because we have 2 variable declarations. So let me remove the other one, which we don't want. And now we get one. Scope length is 1. Which is correct. Okay. So let me see. So we declare the I variable, then we resolve the initializer, then we define the I variable. Okay, then we go out here and we go into the while. The while statement, we first resolve the condition. I wonder if that is failing. Let's say while true. That's interesting. So it's actually it seems like it's failing like here in the. Okay. Anyway, so we resolve the expression of the condition. So let's go into expression resolution. And it finds that it's a logical operator. It tries to resolve the expression. And it should find that it's a variable. Let me write here resolving variable name. Okay, it's resolving it 3 times, which is correct. And let's also print length of scopes. So let me try this one. So it finds that it has been defined. Then we say resolve local. And resolve local. Goes in here. Solving at distance. Oops. Should be that. Okay, the first one is resolved to distance 0. That's correct, because they're in the same scope. The second one is resolved at distance 1, which is correct because it's in the enclosing scope. And it's a bit weird that, because there's 2, right? So, no, wait, okay, so we have 1, which should come from the I less than 10. Then we have 1, which should come from print I. Then we have 2, which comes from this I and that I. So it's all correct. It's all correct. The problem must then be that we're again using like the wrong ID or something, which we also had problems with in the other video. So let's see here. Resolve. And it says get ID. So actually, let's just do like this. ID is this thing, which is expression.get ID. Okay. And here, when we are saying ID is something, what is the idea? ID, the ID is this thing. The ID is 1, but so that should be that one. So why is it none? Then we have to go into environment, into get. I should probably clean this up. But hold on. Hold on, no, wait. So the distance is already something we get here, which is supplied when we evaluate. So really it's in the interpreter. And the interpreter should call here, so to get the distance. So getting distance for ID something. Exporter get ID. Yeah, so again we have this very, very annoying thing that the IDs are slightly wrong. So in here we use the the initializer. I wonder if that's, is that what we want? Maybe. But it's using something else, which is probably the variable declaration. Oh, hold on. Resolving at distance 0. Where is this resolve local called from? Do we? I don't think we should hit. Well, we should, but let's. Let me see here. So we should hit in the assignment only once, I think. And I think that's that one. Yes. That's okay. That is okay. Wait. Getting distance for ID 0. Let's see which one that is, actually. So we passed them, that should give them the IDs. So let's do this and get ready to see a lot of output. All right, there's only one. But these are the statements, which is not the expressions. So it's not really useful. Let's remove it again. Okay. So it's resolving. Let's try something a little bit simpler. Okay. I think we should hit here, right? Yes, we do go in there, then we resolve the expression. And what? Let me see again. And then we resolve the initializer. Okay. Resolve expression. It's a literal value, so it doesn't do anything. But then when we say, let's try this. So now it complains. getting distance for ID equals to 3. Getting distance for ID 3. Let me see. But is that ever resolved? Resolving ID something at distance something. For some reason, well, hold on. So let's forget about ID3. So we say resolve ID1 at distance 0. And then here it thinks that it has the right ID, but has the wrong distance. And the distance comes here from the, but it's using the, it's not, but it's not, yeah, it should be that one. Okay, so after looking around a little bit, I think I know what the problem is. We actually use not the initializer. Right, so let me see. So we have a variable, resolve it. And that resolves on the initializer. And what is resolving again? It's just looking for something with the name. What is this? So we can interpret this one. Right, that seems to work without a problem. Then we try to interpret the B thing. And what is this? Yeah, but like, so weird. Oops. So we have this resolve. Resolving. Let me remove some of these stupid debug statements. And let me just like do that. So how come there's only one that gets resolved? Let's do that and do this. It's ID1, which makes me think it's this one and not that one. So what happens here? So we declare the token B and then it says resolving ID1. Okay, I think the problem could be that when we go into resolve the binary operator, we resolve on the left one? No. Yes, okay, so we go in and we say, now we figure out how this thing should be resolved. And it will go up here and then we'll use the ID of this one. But when we do the interpretation, we try to use the ID of the full initializer. Which is a little bit, this is so error prone, this approach. Maybe it makes sense to like add a parameter to this function, which is something like resolve ID, which is like maybe a usize, and then we add that. Then we need to fix up a lot of places, so we'll say here resolve ID. And finally, we need to say like ID to use. If it's nothing, then we use the ID like that. Or if it's some ID, then we just use that ID. And then in this one, where we call resolve, perhaps we just like pass the ID instead. Then we go down here, and it shouldn't be an expression, it should just be an ID. Like maybe that will work better. And now if we run the compiler, there will be a ton of error messages, so I will fix those. But before I do that, so the idea is that we declare a variable and then we say that when we resolve the initializer, it has to be stored under the ID of the initializer. And then presumably we can do something similar here. When do we call resolve variable? That's fine. When do we call resolve with an expression? Just an expression statement. Okay, so in which context would we hit this function? I'm not too sure actually. I guess if we have like assignment or a call or something. So anyway, I think at this level it should just be none. And if we print, it should also be none. If we return something, the condition, I'm gonna try this. Right, and here we have to say sum. Anyway, let me just go through these errors. Okay, so that kind of fixed it. And at least for now, like if we run this, it actually runs without throwing any kind of error. So let's say, let's try to run this code again. And let's see if it fails, and of course it fails. Right. So it's resolving things correctly, like it's getting the right distances. But yeah, it's still there's some problem. So let's see. Let's check out the print statement. Print statement. So let's try to see print distance. And no, okay, it's still. So that's interesting. So this runs without any problem, but this doesn't. What if we do this? No, it still doesn't work. So for some reason in the while, so what happens in here in the while statement, we try to get the distance to the condition, and when we resolve the while statement, we resolve we should use the condition. We can try to say just this, see if that works. It ran. I actually expected it to run forever, but for some reason it did not. Because I said while I is greater than 10, so let's actually try the correct way. And now it ran. So I'm still very, very suspicious of this code. And actually kind of don't expect it to fully work. Let me do this. That one is okay. Is there something here? Print some debug statements here. So that one shouldn't be there. That should be there. That should be there. That should be there. How about in here? We don't want those. And this one. And this one. Let's try to run it again just to see. Okay, just prints 0 to 9, and this one we can ignore again. Okay, let's try to run the tests, and it did not work. So let's try to go test cases, font can't return, and it looks like this. So we can run that, and it again says variable a is not defined. Close that one. So we can probably like reduce it a little bit to that, and still fails. This should work, I think. Yeah, that works fine because it's not really doing anything. But this one should fail. Okay, so evaluate. No, interpreter. So we have a function. Function statement, return statement, statement block statement, var statement. So it's an expression. Well, it's actually a print statement. Distance on print. Is none, which is fine. So then we're going to evaluate, and it should be a call. So it's evaluating the call. Variable A has not been declared. That's fine. So we do get the callable. Otherwise we would have hit this error. The number of arguments is correct. And we will say getting arg value, this thing, and maybe it needs to be like that. So that's correct. And then we call the function. Okay. And right, so it's Corley, which is a reference. It's evaluated on the environment, which gives a function. So that should return the thing that's defined here. So it should like go in here. And I think it should go at least this far. So we go into the implementation. We get our interpreter. We define all of these variables. And then we interpret all of the expressions in the body. But then this is interesting. So because A is never really resolved, I think. Oh, it shouldn't it be? If we go in here, there's a function statement. So we resolve function, which declares and defines the function name, then resolve function helper. Goes in here, it says defines, and it has its own scope. And defines and declares and defines the parameters. And then we resolve the body. Damn. So what does the could it be this thing? Let me try to remove that. So no, that doesn't work. How about this? So that works fine. But this doesn't work. Resolve. How about let's check if it's just it's not just the return statement, it's everything. Let's see what the interpreter is trying to do. Well, we cannot do that. Let's go into the resolver and just like keep track of what we are actually resolving. So print name, should be name. And it should be named.lextheme, it should be ID to use, and it should be size -1 -I. So we are just resolving a single thing. Which is interesting. Okay, resolve function helper, it should resolve all the expressions in the body, so it should do the return, which is resolve expression. Wait, let me see. So return statement resolves on the value. And the value here is a binary one. Okay, so wow, this is really something wrong with the structure. Because yeah, here we're getting the distance on we're getting the distance on a -1. So just to test something, would this work? No, it also doesn't work. But at least now it's like, what is this? What is this 3? Ah, right. Okay, so it's this thing that is trying to resolve and should look in the global scope. So that's correct. And then there is this A, which is also correct. Let me see. Up here, like, I want to do print value.getID. Yeah, so it is. Everything is looking correct, so why is it complaining? Because the distance it gets is none. Even though... So weird. Okay, wait a second. Just locals. So what do we do here? The locals is just a new one. It's not... That's the problem. Okay, so this one, say parent locals, dot clone, and that did not work because I made a colon for some reason. And this will not work because of this thing. So we're gonna say locals is we're gonna remove that for now. Pretty sure it will not work, but I think it has to be thought out. Okay. Great. We need to remove it here. Okay, so now it worked. And now we have another test failing. Because it's printing like a bunch of stuff. It shouldn't be printing. Okay. It's the same test that's failing for some reason. So let me do this. That is annoying. Let's try this thing. So that doesn't work either. Okay. I think we're gonna call it for this video because we've been going for a long time. And I think I need to reconsider how this resolution is done. Because this current implementation is just too buggy and too difficult to work with. But I'll see you in the next video.